So, welcome to my dear students and learners. So, this is a requested video about the journal bearing. But I'm extremely sorry that I was trying to start this course long back, but my office schedule is so tight that I am unable to find the time to sit with you. But anyway, now I am starting this course, and where I will mainly focus on journal bearing, mainly on hydrodynamic bearing and its basic principle, the mechanism, and the design, how to design it, then the maintenance, the predictive, mainly on the predictive maintenance, means what are the parameters are to be observed for uh, enhance the life of the bearing, etc., etc. So let me start today's this. It's a introductory session where, without going more detail with mathematics, like pictorially or with your common sense, you can understand the concept of journal bearing. So, what is bearing basically? Bearing is a machine component that reduces the friction between moving parts to allow smooth motion, okay, such as rotational motion or linear movement. By supporting a load and guiding moving parts, bearing facilitate relative motion while minimizing wear and tear and increasing the efficiency. So broadly, if you see the category of the bearing, so normally it is like anti-friction bearing, like your ball and roller bearing, etc., etc. So this one, and another is plain bearing, or like sliding contact bearing, or sometime it is hydrostatic or hydrodynamic bearing. Okay, so this is that normally a fluid bearing, okay, or the sliding contact bearing. So what is hydrostatic, what is hydrodynamic, all these things I will come slowly. So basically we are going for the, basically it's a plain bearing, means it's a journal bearing. The name is journal bearing, so we will be focusing mainly on the journal bearing. So this is the very common structure of a journal bearing. So normally this part is the outer casing or the housing, and inside that, this this black color or the gray color, so this is the basically the sleeve or the bearing, and one shaft, and in between the shell and the shaft, there is very minute gap will be there, and that gap will be filled with some viscous liquid, uh, to which will basically that liquid, due to when the shaft, and the journal is basically the portion of the shaft inside the bearing, okay. So it is the, this is the extended or the enlarged picture of the of a hydrodynamic bearing. So this part normally it will be, this is white part, this part is basically made of cast iron generally, and this orange color part, this will be basically the bearing, and inside this is the shaft or journal, whatever I told, that the basically it's a shaft. There's a portion of the shaft which is inside the bearing. Okay, so in this case, this from here to here, this part, this section of the shaft is called the journal. Okay, so once the shaft, so initially due to the load, the shaft is touching the bearing surface, inner lining, and once the shaft started to rotate uh, based on the RPM and the oil viscosity, okay, and the gap between the journal and the bearing, this shaft, the liquid will create some upward forces which will basically lift the shaft. Okay, this is basically the mechanism. We will know slowly. So basically, the this hydrodynamic bearings are comparatively less efficient, and they need some sensitive lubricant. Okay, because the viscosity of the liquid is very important. How the how quickly the oil film around the journal will form, and how much uh, uh, lift force it will be introduced to uh, rotate the rotordynamical part without any friction and wear and tear. Okay, even though this is less efficient and so many crucial design calculations are involved, but grossly the components, the part of this bearing are very less, hence it is ensuring the simple design, and they can handle extremely high load. Theoretically they can last forever. Okay, because as there is no wear and tear, so this can theoretically this can last forever. The rotating component of the bearing is called the journal, basically the shaft. Okay, as I told, the journal is the part of the shaft which actually rides inside the bearing. Okay, uh, and normally as the shaft will transmit the power from the um, prime mover to the driven equipment like pump, blower, fans, and whatever may be. So normally it will be made of some strong materials like alloy steel, or like a pump. If you see a pump, normally it will be very uh, hard material, strong material like alloy steel or stainless steel. Okay, and sometime this shaft it will be um, uh, this journal section. Okay, it will get some additional extra treatment like chroming in order to improve the hardness and wear resistance, because there is a possibility that it will touch the bearing. That time the rubbing kind of things it will be there, so we need to increase the wear resistance by harden the surface of the shaft, normally which is called chroming. Okay, these are the so many things are there, we are not going in details of that. Okay, so sometime, so if you see this picture, as I told, this is the outer casing, normally it will be made of cast iron, and sometime here in between the bearing material, the black color, this black color is the bearing material. In between the outer casing and the bearing material, some pad will be there supporting to uh, increase the stiffness of the structure. Okay, so the sometime it constructed in two or three different layers. The outermost layer is always some kind of strong support material. Normally it will be cast iron, and oftenly there will be a intermediate backing layer on the top of the support material, and the final layer is basically the soft bearing material. So this means this black color portion, basically it is the bearing, or you can tell the shell, that will be made of very soft material like copper alloy or aluminum alloy, and most commonly it will be made of bavitt. It's a type of white metal. Basically it is also a alloy that will composed of lead, tin and antimony, copper, etc. And this bearing material is so common, that bavitt, that so oftenly it is used, that this kind of fluid bearing, sometime it is called bavitt bearing. Frankly speaking, when I came across this kind of journal bearing, I used to um, I see the my seniors experts, they used to tell bavitt bearing. Okay. Normally, this bearing materials are, why these bearing materials are, there may be a question in your mind, that why this bearing shell or the bearing material is made of soft material and white metal, and the shaft is so much hard material, and it is extra treatment hardening also it is done. Okay. So basically this bearing is treated as a sacrificial component. That means it will sacrifice to protect the shaft. If there is some metal to metal contact between the sliding surface in the bearing, then the bearing shell will wear this will the bearing material will wear before the shaft, and it can be replaced, and it is always cheaper to reline the bearing compared to replace the journal, because it's a part of the shaft. Okay, so that is the reason the bearing is made of some uh, soft white metal. Even though this construction is looking is a very simple, but a very crucial physics uh, that play in hydrodynamic bearing, uh, to understand its detailed operation. Okay, now let us start with the sequence. So the first, what will happen when the your rotating machinery, say there is a horizontal turbine system, so when it is off, uh, then the journal is touching the bearing material. Okay, so during the design you should very careful about the clearance between the bearing and the journal, which is basically called the gap. Okay. Normally in the picture you might have been seen that you can see that, because in the previous slide you see the gap is, you can see by you see huge gap is there, but actually it is not. it is a very very tiny gap, like even though less than a human air diameter. And the clearance, as I told, it will be filled with the lubricant, usually oil, or sometime uh, the liquid which you are handling, that itself um, responsible to generate the oil film across the journal uh, when the impeller or the shaft reached a particular RPM. Uh, so, what I was telling, when the machine is off, the shaft is not rotating. So, the weight of the shaft and the entire other rotating components or impeller, whatever you can say, they cause the journal to sit at the bottom of the clearance, and there is a metal to metal contact. And you can see here the gap, the yellow color portion, it is not uniform everywhere. Okay, this will be important when we turn on the machine. So uh, when we are, say, the motor is on, so what it cause, what is the mm, mechanism or the component responsible for the bearing action or lift up the entire shaft. So in this aspect, the fluid plays the major role, and one parameter is very important, which is called the uh, viscosity of the lubricant or the liquid. So any fluid, basically, it is made of many tiny little molecules, and there is some intermolecular forces of attraction in between. So when a liquid flow, the layer of these molecules slide past on one upon another. It will means one liquid, it is attract the subsequent one and pulling each other. Okay, so this will cause the resistance of to flow. Basically, that will indirectly measure with a parameter called viscosity. So to understand that, let us go back to our ninth or 10th standard. I can remember during my school days, I have seen this. I think all you are familiar with this picture. So I can't exactly remember that book name. It is a Maiti Bhattacharya and Chhatra or something like that. One book was there. So this in the liquid uh, fluid, that hydrostatic, in that chapter, buoyancy and hydrostatic, one chapter was there this I get familiarized with this concept or the experiment when I was in ninth standard, I think. So this experiment was carried out by Sir Isaac Newton. So he was trying to establish the quantitative definition of viscosity. So to understand this in a simple way, he did one experiment mm, where uh, some liquid is sandwiched between two plates. So this bottom plate, which is at rest, and the top plate, it is moving with a velocity, say v, some velocity, and he was trying to measure the um, uh, liquid velocity, the layer, the velocity in different uh, in this direction, in this direction. So what you observed, that the liquid which is just sticky to the inner surface of this top plate, those liquids are um, flowing with uh, velocity at most equal to the velocity at which the top plate is moving, and the slowly when it is going away from the top plate, the velocity started to reduce, and at the bottom plate which is at rest, so that there is no liquid velocity. And this phenomena, this gradually uh, degradation of the velocity is more prominent if you replace the liquid with some higher viscous liquid. So, in this way, Sir Isaac Newton first tried to conceptualize and quantify the parameter viscosity. And as I told, that parameter is very important to design the journal bearing. Now I will tell another one phenomena which is called aqua planning. I means planing. Like it is sometimes called hydroplaning. So you can who are driving the vehicle or car, they can experience this phenomena. I experienced it in very well. So when you are going along road, but don't do it uh, in a highway. So if there is a stagnated water and you are trying to say somebody want that my car inner chassis will be uh, cleaned naturally, so they will run their car in the through the stagnated water in the road. So what will happen once you are just entering in that stagnated water area, suddenly you feel that your car started to float and you are losing the steering control. What happening basically? So this your uh, say this your tire is rotating in this direction. Okay, so due to the viscosity, what will happen, the same as the earlier picture what I shown you, what will happen, the water which is just sticked with the tire, that having higher velocity, and due to that what is happening, uh, see, once it is your tire is entering in the water with some uh, cars say some speed, so what will happen suddenly, initially there is contact between the tire and the road. Okay, suddenly when you are going inside the stagnated water, what will happen, due to that velocity, some higher pressure will develop here and it will try to push the water like this. That gap is very minimal in this case, and once due to this pressure it is slightly lifted, then what will happen, this the water which is just at the outer lining of the tire, it having the higher velocity, and comparatively the water which is sticked in the road, that having the lower velocity. Okay, so in such case, you see, if you can see this area, water velocity it will be high because your tire is rotating say at 2000 rpm, but comparatively this the that this surface which is just above the road, this is a very less velocity. So here one concept is coming, which is all which is Bernoulli's equation. So the Bernoulli's equation, what it told, any flow, any streamline, okay, or the in the flow line, the total pressure, which is basically summation of static head, dynamic head, and the elevation head, is always constant. So now I can say, because this thickness it will be very less, so the elevation head I can consider as it is nullified in the both side, but the dynamic pressure here, it will be much more. If here this area, your dynamic head, it will be much more, and this area as it is stand still, so here the dynamic head is very low. Okay, so now you can think of that when your flight is just about to landing, so that time the aircraft velocity is getting reduced. So velocity getting reduced means your static pressure will increase. So that's why in air you will feel some pressure. So in that similar way, as the water in the uh, outer lining of the tire is very high, and in the water which is just sticked on the road, there is very less velocity or approximately zero. So there is a pressure difference in here and in here. So due to that, the static pressure, as per the Bernoulli's equation, the static pressure will be very high in this area, and this static pressure is zero. So due to that, sorry, this area, as the dynamic head is more, okay, as the dynamic head is more here, so your static pressure will be normally less, and here your dynamic pressure, dynamic head is very less, so static pressure will be high, and due to that there is a lift. Okay,